All right, let's figure out the boring stuff first. How many sides does a triangle have? How many angles? 3. Okay. You are so awesome. So we're on page 1. And it says page 1. Can you find it? Okay. Now, on this triangle over here, when we look at the 3 sides, this side, we're going to name it with 2 letters. What 2 letters are we going to use? Okay, so we're going to call this X, Y, and we're going to put a segment over the top of it. So I know that X, Y are connected as a segment. It's the side of the triangle. Okay. No, I'm not playing solitaire. What would we call this side? YZ. And then we could call this side XZ. If you call it ZX, that's fine. Okay. And then I want you to understand that when we name angles, we do this. We say angle X, angle Y, and angle Z. I am sorry. I have no control over it. Okay, so then we have this really cool thing called the triangle sum theorem. Who can tell me what the sum of the measures of 3 angles in a triangle always is? Thank you, Ian. 180 degrees. So we know that the measure of angle X plus the measure of angle Y plus the measure of angle Z equals 180. When we put those 3 together and set them equal to 180, voila. Okay. Measure. So that means you just take the numeric value. So like 60 degrees or 54 degrees or whatever it may be. Okay. Okay. So this is what's going to happen. I'm going to give you a card. That card is going to tell you which whiteboard to go to. And at the whiteboard, you are going to work with your 2 or 3 other group members to solve a problem. Nope. You're welcome. Take your card and meet your group members.
Hey, Joe.
Nope, in your packet. I want you to solve for X and the problem that I have up on the board.
We go to the number or board or something?
Yep, that's it. Ace means 1. Wait for your group. The 3 of you or 4 of you have to work together.
They'll solve the problem. Move your head. That's number 8. Yeah, we're doing it. Yes. Yeah.
Where's a marker I can use? Hand me that. Don't worry, guys, I got it.
That is. I think you put that. I look at them how to nine.
I'm not doing this.
I need this. What ends?
Really? I'm working on it.
Okay, when your group is done, I'll take your card.
Why not? Flipping light work.
No, it isn't. That's what you're solving for.
You saw me.
I don't know the judges.
We have to have the table. What is this? Oh, there's 2 pieces of puzzle.
I have 18 cards. I should have 25. 19, 20, 21, 22, 23, 24, 25. Okay. Okay, so what I want you to do is I want you to look at this problem number 1. What do we know about these 3 angles? Okay, so we can say, oh, hey, 79 plus 82 plus X equals 180. Right? Oh man, I know we're coming off of a really long break. What's 79 plus 82?
169.
So what's X?
19.
X is 19. Cool. Now, in number 2, is that box? You actually know that, or did you look at the board? It's just common knowledge at this point. Okay, this box right here means 90 degrees. So 53 plus 90 plus X should equal 180 in this example. Three angles of a triangle, no matter the triangle, will equal 180, no matter what.
What if it's like 54 degrees and like 100 degrees? Like 180 degrees and 1 degree.
It wouldn't be a triangle then. Okay, what's X?
What if it doesn't?
For real. If it's not 180 degrees, it's not a triangle. Ah. Okay, so as I look around the room, it appears that a lot of us got X equals 8. Let's talk about that. I don't know. So over here, who was in group number 8? Reese. What is this right here? Okay, so you took each of the 3 angles, 5x plus 1, plus 14x, plus 4x minus 5, and you knew that they had to add up to equal 180, right? So then if we combine like terms, looks like that was the next step, right? We have 23x minus 4 equals 180. So we combined all of the terms with x's. We combined all of the constants. DJ, are you good?
Yeah.
Okay. Okay, now what do we do? Huh? Add 4. So we have 23x equals 184. Just get it over with. Rip the Band-Aid. Okay. And then we would have to divide by 23 to get x is 8. Okay. Now I really like, who was group 7? Group 7 went above and beyond. Do you see what they did here? How did they get these numbers?
I thought we were supposed to put the X's in.
Okay, so let's just do this. Can you do this with me? Can you label these A, B, and C? So like if I ask you for the measure of angle A, well, the measure of angle A is 4x minus 5. So how would we get the measure of angle A?
Eight times 4 minus 5.
That's excellent. 4 times 8 minus 5, which is what?
41,
Neither of those are right.
Wait, what?
4 times 8 minus 5 would be 27.
See, look, I did it.
I'm
On that.
Nope.
I just don't want to math today.
Fair.
That was a phenomenal threat.
All right, how about the measure of angle B? We know angle B is 5x plus 1. What's 5 times 8 plus 1? Okay, I'll tell you, it's 41 degrees. You guys are slow today.
Knew it.
All right, and then how about the measure of angle C? Angle C is 14 times x. Can you see?
What does that say? Does that say 23? Right there.
You need glasses? Oh wait, she is at the front.
That's up front. Like you guys sitting at the front.
Oh, you got like a standalone lawn chair right to me.
You can sit in the naughty desk up there.
You should be.
All right, we're gonna go to page 2. Okay, here we go. So I'm gonna go ahead and skip number 9 because I really truly believe that you're gonna be okay with those. And let's talk about the types of triangles. Okay, what's an acute angle?
A small one.
Angle under 90 degrees.
An angle less than 90 degrees. Oh, cute. Okay. So if we have all acute angles, so every single measure is less than 90 degrees, then it is called an acute triangle. That's angle. This is the symbol for angle. What is an obtuse angle?
Big, over 90 degrees.
Okay, so if we have one angle over 90 degrees, can it have two angles over 90 degrees?
No.
No, because then it's not a triangle, as we've discussed thoroughly, unfortunately. If there is one obtuse angle, then it is called, crazy, an obtuse triangle.
It's like if it's over 90 degrees, then it's automatically like up to, it's kind of like bad. Not very nice.
So if you need a way to remember, like obtuse, are you comparing it to the word obese? Is that why you?
That's not very nice though. Like, it's trying to say like, you have to be only 90 degrees. It's sort of like, cute. It's not nice.
Okay.
It's funny though. No, it isn't.
Okay. And then what do you think we're gonna call a triangle with one right angle?
A left triangle.
Our left triangle would be acute and obtuse. Oh, I don't think that you can understand my coolness level. Yes. Okay, so every triangle we can classify by its angles and by its sides. Okay, so you know what? We're gonna start all the way over here. All sides congruent. Okay, if all sides are congruent, then they each have a mark that's saying, hey, all these three sides are the same, or they all have the same, like they're all 666 or 555 or 700, whatever it is. If all three sides are the same, you know what that's called? Equilateral. Hey, I can spell. Okay. Now the middle one says two congruent sides. So two sides are the same and one side is not. That's called isosceles. Hold on, but I can't spell it without. Okay, and then he already gave it away. If we have no sides congruent, every side has a different measure, then it is called a scalene triangle. Okay, so I'm gonna give you 2 minutes, and you and your new elbow partner, introduce yourself if you haven't, are going to work together on 10 through 15 and classify by both the angles and the sides. So is it acute scalene.
Equilateral.
There's two names for everyone.
This is nice.
Isosceles? Yeah, isosceles.
I think
That's up to.
I think it's a sausage.
We give her number 11. This is right. Oh, equilateral. What would you get?
Hold on, wait. Oh, yeah. Even better. Actually, that does make it more saucy.
Up to.
You don't go brother.
I think we got right skin. Wait, what is it? How do you do all these? I think
Yeah, you're gonna save it.
Okay, give me a thumbs up if you're still working. You're still working. You're still working?
Yeah. We're going to this time. I didn't tell you to do 16. My bad.
what's It's 12 sides. No.
What's the one with mine?
I don't think Adrian's have 14. Did you have the 12 going around? What?
Okay. Okay, Zayden, what is number 10? Right, and awesome. Reese, number 11. Acute equilateral. Will an equilateral triangle ever be obtuse? No. No. Will an equilateral triangle ever be right? No, because the angles will always be 60 degrees. No, equilateral is always acute. Connor, what's number 12? Obtuse, scalene. I'm hearing people not named Connor talking right now. Izzy, what's number 13? I don't care the order. Isosceles and acute, very good. Cassie, number 14. It is isosceles. What's this missing angle right here? Yes. Because this guy would be 118. Okay, and then Harry, what's number 15? Right, and scalene. All right, so let's look at number 16. We need to classify triangle JKL by its angles. What should we do first? Before we find JK and L, we better find X. Well, here I have three angles, J, K, and L. What do we know about those three angles? Interesting. We know that they add up to 180 degrees. So what I'm going to do is I'm going to take the sum of those three angles and I am going to set that sum equal to 180 degrees. Those like fire Cheetos hanging out of your bag there?
You got me ready.
No.
Fire Cheetos?
What are they called?
Fire Cheetos.
Hot Cheetos.
Hot Cheetos, whatever.
Molten lava Cheetos.
Fire.
235 Cheetos.
Okay. Let's combine like terms. How many X's do we have?
Wait, hold on.
25.
How?
Is it 25X?
25x plus 25x plus 5. Where are you getting 9 from, Reggie?
25X
Henry's.
Plus 5.
plus 5 equals 180. So 25X equals 175, right? So X equals, okay, but I don't care about that. Okay, I mean, I care about it, but that's not our ending, all right? So let's talk about the measure of angle J. The measure of angle J is 5X minus 3. Well, if X is 7, what does that make angle J?
32.
Do you agree with Gabe? Please confirm. 5 times 7 minus 3 is, what'd you say?
32.
32, okay? Then we have the measure of angle K. Well, the measure of angle K is 11X plus 13. Well, if X is 7, 11 times 7 plus 13, exactly 90? Interesting. And the measure of angle L, 9X minus 5. Are you okay?
Yes.
That's great. 58. Now, we don't know anything about the sides, but we do know something about the angles. And since we know all three angles, we can classify this triangle as right. How do you know it's scaling?
None of the sides are the same.
How do you know none of the sides are the same?
None of the angles
are the same.
Since none of the angles are the same, you're saying none of the sides will be the same?
Yeah.
Do you believe it?
Saying that pretty confident.
No? I mean, he's right.
Yeah,
No,
it is.
yeah,
It's
you're
right. Okay.
Yeah.
Well, you're making me second guess myself. So
I'm sorry.
You go like, wait, am I right? Wait, no, I'm not right.
Okay, so your homework is all of page 3. Now I have somebody panicking. His name may or may not rhyme with Byron.
Oh, wow.
So he's really worried about problem number 5. Okay. What do we know about angles 5 and 6? Look up there at my drawing. What do we know about angles 5 and 6?
And they're part of 90.
5 and 6 should add up to equal 90. Okay. Okay, let me help you with this. Okay, so you see 3 triangles, but there's really 5 triangles here, guys. You can use this triangle to help you. Do you see it? You can use this triangle to help you. You can also use the fact that this is a straight line. And so what do we know about those 2 angles right here? Interesting.